Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So the first thing we need to do is calculate the amount of MnO4 minus that we used to use during the titration. And with titrations, we often use them to determine unknowns, where we have a series of knowns that we can use from other materials. The amount that we use is 0.00372 moles of MnO4 minus. So now we can relate this value to the moles of H plus from the acid in the sample, from the oxalic acid in the sample, using the stoichiometry of the reaction. So then we have 0.00186 moles of H plus in the acid. So now we can use the mass of the acid. That can be determined using the molar mass, where we have 0.167 grams of oxalic acid. So now we can calculate the total number of moles in solution of H plus. That is 0.00272. So now we can calculate the number of H plus moles that originated from our acetic acid, and therefore we can determine the mass of acetic acid. So the H plus moles from acetic acid would be 0.00086 moles, and then we can determine the mass of acetic acid. That is 0.0517 grams. So we can now add the values for the two masses to find the total mass of the sample. So we have the total mass of acetic acid, that is 0.219 grams. We can find the mass percentage value for each acid. So we've got acetic acid, and then we have the other acid in terms of percentages. For acetic acid, we have 23.6%, and oxalic acid is 76.2%.